This time for the engine usability, I tried to go do that camera thing again, but it still came out pretty sloppy, just because if I were to actually do it correctly, I would have to modify a lot of things in Azul just to get it to work the way I wanted it to, using my sound conscious class, which is the 3D sound listener for my sound engine. But it felt weird modifying so much in a library that I decided not to go through with it, just because I didn't want to hack so much of the internals. It felt like I shouldn't be doing that. Um, but what I managed to do was I did manage to create P2 cameras, which is just derived from camera, and I can basically, with my sound manager, just set that camera. So I can set the current camera, and it just sets the cameraman's current camera, because I modded it. Oops. I modded it so that the cameraman has a current camera, and then this is the default camera, which is the original one. I added these two functions, which is just getting the default camera and setting the current camera. And P2 is derived from that camera, so that's why it works. I tested it out, and I could get it to swap between two cameras, but I could not add sound listening capabilities to the default camera because it's of camera type, and that's where I felt it was a little sloppy to try to change so much of Azul. And that was pretty much it in terms of trying for the camera stuff. I may not end up doing it, or I may end up doing it. I don't think it was super necessary for my individual project or for the engine usability, even though that would be good. I think it's more of like another mini individual project, so I don't really have time to do that, and instead I prioritized on my sound system and the testing how well my sound system works for the. So for another part of the ease of use, I decided to kind of stress test how not how I want to say useful, but how easy it is to use the sound engine that I've created, in terms of just being able to play sounds and stopping them and all that kind of things. And I found out overall it's pretty easy to use. It's kind of what I feel would be the standard, where you just have, for instance, I have a sound 3D pointer that I get a sound, so a tank shot sound in this case, and in order to play it, so when it's created, I just call play on it. By default, it's a single burst, so it's just going to play it once. When it ends, then it stops, and that's it. But you can keep calling play on it when you're actually using it. So it has all these kinds of functions, just to show a few. Some of these are public, but they should be private. I just left them public so I can test the sound very easily. So I have the kind of regular stuff, checking if it's playing, getting the sound position, because this one's a 3D sound, pausing, playing, set looped, set position, and set volume. The 2D one has the exact same kind of functions, except for getting and setting the position, because the 2D sound does not have one. And one thing that I discovered from using the kind of engine is having a 3D sound. Like, a lot of the times there would be a game object that has a specific sound for it. So like if it's a bullet, you would imagine it having like a whirling sound, or maybe just the pop of a bullet when it's first created. So it would be useful to have an audible class, which I've started but I haven't finished yet, that just pretty much allows you to attach, in my case, just one 3D sound object per game object, but you can still have the ability to add 3D sounds to the game object. So if you have a game object, you can just create a 3D sound using this. But it's not automated, so you would have to set the position of the sound. What I'm talking about, the audible ones, is automated, in which if you set the game object's world, it also sets the attached audible 3D sound. So I'm going to kind of break down the things I've done for the individual projects in chunks, just so it's easier to understand, or just so that it's not so all over the place. So I'm going to showcase the changes I've made. So from the sound manager, which is pretty much my sound asset manager, I separated the create sound instance to two, where it has a 3D and a 2D. And it has recycling already. I still have to test out to see if it's completely working properly. but the recycling does work for 2D and 3D sounds. So I have it separated just so I don't have to do any casting. And pretty much when you're creating a 3D sound, just like here, 3D sound, you would call the get sound 3D, and then if this is 2D, you would obviously call the 2D sound. So that's what I've done for the sound manager in terms of changes. One thing I want to talk about is the sound consciousness, which is just an UBL that I attached to my game object. Pretty much all it is a position and the direction. That's the only data types it has, because that's all Erkland needs in order to calculate the correct sounds, how it would sound in 3D space. And I have a sound conscious state because there's only one allowed, so pretty much when something is set to the listener, it gets the current listener and sets that to not listening, and then it sets a new one to a listening state. And pretty much when you call update, it updates the values of the position and the direction. But I just now realized that this is okay. But what I ended up doing for the game object, which I will fix, is I ended up setting the collision world in position before I update, when I could have just updated here with all these values, because my state pretty much says that if you're not listening, don't do anything. And if you are listening, then actually update Erkland's listener to be your own values, and that's how the sound consciousness works. So in my case, it's part of the game object, so when a game object moves, it updates the sound consciousness values. But I don't need to do this. I could just put this in here as parameters, and then that way it won't actually do anything. This actually sets the position. And that's pretty much how the sound consciousness works. It's just pretty much the direction. And sorry, I forgot to mention how to do the sound system, what it actually does for the listener. Pretty much it gets a sound consciousness new listener. And if I'm going to remove this later, I'm pretty much going to replace it with a no listener as being the default, just so I don't have this if statement. But pretty much it gets the previous listener and sets it to not listening, and then it gets the new one, gets all the information from it, sets the Erkland engine's listener position, and then sets it to listening. This way it'll update itself whenever a game object moves. And that's only one in the whole scene, so that's why this works. It removes the previous one, sets it to not listening, and then sets this to listening. So pretty much one thing I changed was the sound class. It used to be an actual just sound, and then this is what you would play, set loop, etc. But what I found easier is pretty much to separate them out and just have the sound be an abstract class. So now I have a sound 2D and a sound 3D class. Whereas you would imagine the only difference is that one of them has setter and getters for the position and the actual positional data. And the sound 2D is just getting its play mode, which is by default the burst 2D mode for 2D sound. And then when you play it, it just tells the sound system, play me as a 2D sound. And if you set this to looped, for instance, where you get the looped one, it would just say play 2D looped. And as you would imagine, the 3D ones are pretty much exactly the same, except they call the play 3D and the looped 3D. So that's pretty much the sound 2D and the sound 3D, just to show a quick glimpse of the implementation of the 3D sound. It looks pretty much the same as the 2D sound. There's like absolutely no difference except for the burst mode sounds, which just tells you how to play that sound. The reason I have the burst sounds is just so that when I set it, that's the only time where you have to see like what kind of state, just because it's true or false. I could have separated it into two functions, but it didn't really matter too much, just because it's not being called at every frame. So like if you played a sound right here, you wouldn't have to check to see if it's looping or not, which would pretty much be an if statement where you're going to be using sounds a lot. So if you play it a lot, you're going to have to use that if statement to check it in the other case, which is kind of not efficient. So this is why I have these kind of states, these modes. So the final thing I had to do is a very small change. It's pretty much for the sound system. I had to add a process sound drops, which is pretty much kind of like determinable, where on a frame you can set something to be terminable and then terminate it on the next frame. And that is the solution to the bug I had. The bug I had was pretty much if I kept spamming a sound, eventually you would get an error, and it was very archaic because when I get errors for like getting the call stack, it doesn't actually tell me the exact location of when it stopped, and that's because I don't have the Erlang public symbols, so I have absolutely no idea what happens in the internal Erlang. So what I was getting back was just an STD bad allocation error, which to me didn't make sense. But I researched online, and pretty much it pretty much said that one of the things that could be happening is it's using you're trying to access a pointer too, so it could be a pointer problem. So I spent 7 hours plus figuring out what was happening, and I pretty much figured out that Erlang's sound callback is timed based. So the second that the sound stops, it's going to in my case drop it before I had it. So when a sound stops, it gets dropped, unless if it's called by user to be stopped. Then if you stop it, technically you would be calling it on a frame basis, but if you let it go and don't call stop on it and it stops itself, then it becomes based on a time instance. So if it stops at a time when something's calling it, so for instance trying to update a 3D sound, which is where my problem was happening, you would be accessing nothing because it's already dead. So what I pretty much did to fix this is I took that time base and I converted it to the frame base by just saying, when you finish, register yourself to be dropped, and then in the next frame drop them. That way it dead stops, goes along with my system, it doesn't cause crashes. The last thing to do is pretty much just show that everything works. So pretty much the only thing I have left is just cleanup code and adding up small functions like being able to set the volume and being able to set the I guess fall off distance and all that kind of stuff for the 3D sounds. So the ship is the listener, and I have this sound tester, which is just a sound I can move manually, but I also have pretty much a bullet that starts at the origin and then goes to the right in my perspective of the camera. So I'm going to actually fit the ship just to show it right away. So I have a 2D sound. If I press 1, that completely doesn't matter where the sound listener is because it's a 2D sound. It still plays regularly. Then I also have the 3D sound, which I'm playing right now. It'll be playing from the bomb, which is my sound tester. So as you can see, it's playing on my left channel. And if I go to the right, it's on the right channel. Hopefully this video recorder captures in stereo. So pretty much is how it works. I can still call stop on it. This is pause. This is starting off. So then I stop it, and then it starts from the beginning. Pause, stop, start from the beginning. I'm going to stop that, and now I'm going to do the bullets. So this is spawning multiple sounds. One thing I also have to make sure of is to make sure that this is in front, and this is in back. It's hard for me to really gauge if the correct coordinate system is working out, just because I don't really know. Me personally, I can't tell if it's in front or in back of the position. So it's showing that rotation also affects it. So yeah, it's pretty much the entire sound system almost done. I would say it's like 95% done, except for those small functions, and then everything will be probably good to go.